This is Mrs. O'Neill for AP Chemistry, Chapter 5, Section 5, Calorimetry. You should have watched the introductory notes on calorimetry. These were mine. He talked about Lavoisier being the chemist who started modern chemistry, and he talked about that calorimetry is just measuring heat. And we want to remember that heat is really the measure of the energy of a system. He talked about the first calorimeter and how he used a guinea pig inside that released respiration, and that's a form of heat. He talked about the parts of the calorimeter. He talked about how specific heat is a measure of how easily a substance, and in this case he talked more specifically about water, can be cooled or heated by adding energy. So if you add heat and the temperature goes up, of course it's exothermic. If you add heat and the temperature goes down, the system is endothermic. So that's one thing that we want to keep in the back of our head, those exo and endothermic terminology. So here he took an example of adding heat to water. And it said that we need 4.18 joules of heat energy in order to do that. So mathematically, where does the specific heat, or Q, we want to keep that in mind, that's what specific heat is Q, but remember we abbreviate it as C on your reference sheet. So just try to understand that he's talking about specific heat, but he's also referring back to just general heat. So how is heat transferred? We always want to remember that heat always goes from hot to cold. It always flows in that direction. And then he talked about a bomb calorimeter, and maybe some of you guys will work with one of these when you go into college. Lots of colleges have this. If we do an experiment in class, it will be a model of a bomb calorimeter using styrofoam cups. So now back to your packet, and I suggest at this point you might want to pause the video, fill in the blanks, and then play to hear my words. So the objective for this section is to examine calorimetry, which is an experimental technique used to measure this heat energy that changes in chemical processes. And it also changes in physical processes. Remember, we can talk about exothermic and endothermic being a chemical change or a physical change. So delta H can only be determined experimentally. Remember, we cannot measure the change of heat energy internally of the system. So we actually have to measure the heat energy of the surroundings. So that's where the Q equals negative Q comes into play. If the system is a positive heat energy, then the surroundings would be negative, and vice versa. So it's the same amount of heat that's being transferred, but one's going to be in the positive sense and one's going to be in the negative sense. If one's exothermic, the other one's got to be endothermic. So calorimetry is just measuring that heat flow. Calorimeter is that device that does that. So what is heat capacity? Heat capacity is the amount of heat needed to increase the temperature of an object 1 degree Celsius. So if we notice these units, this is just kilojoules per degree Celsius. This is different than specific heat. This is how much capacity one substance has to increase its temperature. So this is going to depend a lot on its mass. Okay, where we're going to see specific heat doesn't depend on its mass. So heat capacity is just trying to get us to understand how much heat a substance or an amount of substance can absorb. So it's very similar to specific heat, but it's not exactly the same. Specific heat, on the other hand, is 1 gram. It is mass dependent, okay, or it depends on only 1 gram of the substance. So again, your units here are going to be slightly different. Joules per gram degree Celsius. So it's going to be for every 1 gram, how much does it go 1 degree Celsius? Where the heat capacity, you could just put however many grams in there. So what's the difference? Well, definitely the units, which I just pointed out. So one deals with that 1 gram and the other one doesn't. So read over this and see if you can get the answer. So here is a constant pressure calorimetry, and again, this is that styrofoam cup calorimetry, showing us that if we use styrofoam cup, which is a really good insulator, and we have some kind of stirring device and we cause a reaction in here, we can measure its temperature. If we measure the temperature change, then we can measure how much specific heat something is, or we can measure the surrounding heat. We can get the temperature of the actual system. So that's basically what I was talking about before. Here's our Q of a solution is going to equal negative Q of the reaction that actually happened. So the solution is after we've mixed it all together, we can measure the surrounding heat, and what we really want is the Q, or the heat of the actual reaction that's happening, the system. So this Q equals MC delta T is on your reference sheet. So get used to this, and sometimes we're going to use this again in a different way, where we have to figure out the grams or the specific heat of a solution or the heat that's being released, but then we use that for other parts in that question. So again, a bomb calorimetry is very similar to that styrofoam cup one. So a lot of times they use this for combustion reactions. C for calorie should remind you of calories. Things that you eat have calories. So depending on how much heat is released, that's how they determine how many calories is needed, right? How much energy is needed to burn off or eat up at that food that you're eating. These would be the steps that you would use, so please read over that just so you're familiar with how this would work, just in case there is an AP exam question on calorimetry. There's always one AP exam free response question dealing with labs, so at least familiarize yourself with this technique. Okay, see you in class.